All right, so here's my third tip for integration by parts. If you recognize that you have an integral in the form of e to the power of ax sine of bx dx, or e to the power of ax times cosine bx dx, then your u is either going to be the sine or cosine, and your dv is going to be e to the power of ax. Essentially, what's happening with these problems is that it behaves in this cyclic manner. So what we essentially going to start with is where we're going to end, and it's going to look like an equation in one variable. Okay, so what I'll do is I'll show you with this example. Here we have example 6 that says the integral of e to the power of 2x times sine of x dx. So what's my u here? My u has to be my sine of x. The good news about u being sine of x, we just got to get its derivative. What is the derivative of sine of x? Careful, we're doing derivatives now. It's cosine of x. That's right, cosine of x dx. Okay, and our dv is e to the power of 2x dx. So we anti-derivating here, anti-differentiating. So what is the antiderivative of e to the 2x? Very good, e to the 2x divided by 2. Okay. So by integration by parts, we're going to have u times v followed by v minus the integral of v times du. So just writing this, v times u, I can say we have e to the power of 2x. I can write that in front of the sine function, all divided by 2, minus the integral of, well, just to clear up this integral a little bit, I have v times du. So instead of putting the fraction inside of the integral, I'm just going to pull it out. So I'll pull out the 1/2. Okay, so just note that it is a 1/2 integral of e to the power of 2x times cosine of x dx. All right, now if you look at inside of your integral, this is integration by parts again, because it's in the form of e times a trig function, namely cosine. So you got to apply integration by parts again. So by integration by parts, your u is now cosine. What is the derivative of cosine? Negative sine. Now it's negative sine of x dx. Then your dv is still going to be e to the power of 2x dx. So v is e to the 2x over 2 again. All right. Now we're going to have the following. We'll have whatever was there originally sticks to the rod. So I have to bring all of this good stuff in front of the integral sign in the previous line, bring it back down. So e to the power of 2x sine of x over 2 minus 1/2 of, I'll put in brackets, my new u times v. So I'll have e to the power of 2x times cosine of x divided by 2 minus v times du, or the integral of v times du. But as shown before, since v contains a fraction, we pull the fraction out, pull the 1/2. So we have 1/2 of negative e to the power of 2x times sine of x over, no overs, all divided by, sorry, no overs, no divided by, just dx. Now, here's what I want you to recognize about that integral. One thing that I could do is pull the negative out, no? If I pull this negative out, what do we have? Same thing as the original. So check this out. I'm just going to spend one line rewriting the whole thing all over again, where I'm just pulling out that sign real quick. So I'll say minus. I could clean up the, I could clean up this piece a little bit. I could distribute the negative 1/2 inside the brackets. So negative 1/2 times e to the 2x cosine of x over 2 is just negative e to the 2x times cosine of x over 4. Then negative 1/2 times negative 1/2 is positive 1/4, right? So this is going to be positive 1/4 here. But when I pull the negative out of the integral, this is going to be back to a negative again. So we're going to have minus 1/4 of the integral of e to the 2x times sine of x dx equals the original integral. So this is where it becomes sort of like the idea of that equation that we have, right? We originally started with the integral of e to the 2x sine of x dx. If you think of this as a single variable, and you have it just one side of the equation, then whatever's on the other side of the equation, including a plus c, I'll have to include a plus c and stick it at the end, that would be my answer, right? So essentially what I'm trying to show you is this idea. If I had, 5, this is just a little example, 5 minus 3x plus 2y is equal to, is equal to y, I can take this equation that I just wrote in red and rewrite it in terms of y, right? You would say you have subtract 2y on both sides, you get 5 minus 3x, the y's will cancel, equals negative y. And then if you wanted to, you could have redistributed back the negative on that other side. So I'm sidetracking a little bit here. But there you go. You essentially have your y by itself. So what I'm going to do is move over the negative 1. We're going to move over the negative 1/4 of e to the 2x sine of x dx to the other side. And then whatever that constant multiple is that's still lingering, I'm just going to multiply it on the other side. So check this out. What I'm going to do now is say I'm adding 1/4 of the integral e to the power of 2x sine of x dx. So on the left side, the 1/4 parts will cancel. So we have e to the power of 2x sine of x over 2 minus e to the power of 2x times cosine of x over 4 equals, well, let's think about it. This is one whole integral plus 1/4 of the same integral. So how much of that integral do we have? 1 and 1/4, but what is that as a fraction? 5 over 4, right? So remember, this is one whole integral plus 1/4 of the same integral. So when you add 1 and 1/4 together, it becomes 5 over 4 of the integral e to the power of 2x times sine of x dx. But again, I don't want 5/4 of that integral. I just want 1 of that integral. So I gotta now multiply by the constant multiple, by the reciprocal of 5 over 4 on both sides of the equation. So this answer would become, if I multiply 4/5, we could do a little bit of simplification. 4 over 5 times e to the 2x sine of x over 2. What happens with the 4 over 2 part? That becomes 2. So this will be 2 e to the, just let me try to finish this, my bad. It's just hard to talk over people sometimes. 2 times e to the power of 2x times sine of x over 5. Now, if I take 4/5 multiplied by the second term, negative e to the 2x cosine of x over 4, what happens to the 4's? It cancels out, so it becomes minus e to the 2x cosine of x over 5 equals, well, 4/5 and 5/4, when you multiply them, they cancel each other out. And this will be equal to your integral e to the 2x sine of x dx. But just be careful here. I wasn't finished because what am I essentially missing here? My plus c. So my last line, I'm just going to say that we have, that the final answer would be 2e to the 2x sine of x over 5 minus e to the power of 2x times cosine of x over 5 plus c. And that's my answer. So I'm just going to zoom out a little bit. Whew, what a problem.